So in 9.2, we're going to be plotting linear functions. And so yes, you're going to need a straight edge. You might want to pause the video and go get one if you don't have one. We're going to use what we did yesterday and make some lines. So the word linear here means line. These graphs will all be straight lines. All right, so this is what we did yesterday. We evaluated functions, and we're going to be just doing linear functions today, I believe. So let's see that. So y equals x plus 5. So 0 plus 5 is 5. Again, if they're easy, you can just do them in your head. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. And 4 plus 5 is 9. Over here, we're subtracting 3. So 0 minus 3, negative 3. 1 minus 3, negative 2. 2 minus 3, negative 1. 3 minus 3, 0. 4 minus 3, 1. Remember what I said. If there's a pattern on the left, there's a pattern on the right. Okay, so that can be helpful. All right, so we're going to plot them today. All right, so there are different kinds of functions. All right, we're going to be plotting linear functions. So linear functions, the exponent of x is 1. So only one of those is a linear function. And this is it, because there's a 1 there that we don't write, but that's a linear function. It will be a line when we graph it. Which one is a linear function? This one right there, because there's an exponent of 1 there. That's a line when we graph it. And whoa, what is all that? Yes, this the one on the left. So we're going to be graphing things like you see in the circle, and they will all be straight lines. Okay. This one with x squared, you're going to learn in another lesson, makes this U shape. This one with x cubed makes what I call the bad chair. It looks like that. But notice, those are not straight lines. Yes, the exponent of x determines the shape of the picture. Okay, so we're going to start in the first quadrant. Right, so we're going to do y equals 2x. Now, these are not all the possible x's. These are the easiest ones. We're going to plot the easiest points, right, instead of the hardest points. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. I evaluated that linear function. Now, I'm going to plot those points, right? That's the point 0, 0. That's the point x is 1, y is 2. That's the point x is 2, y is 4. That's the point x is 3, y is 6. And that's the point x is 4, y is 8. Now, again, those are sample points. I could put 100 in here and I get 200. But that wouldn't be very helpful because it's way up above the grid, right? My graph goes from 0 to 10. Okay, but these are some sample points that are on this linear function. Okay, y is always twice of what x is. Y equals 2x. So let's draw this. So you're going to draw a line through it. Now, my straight edge is very wobbly. Let's try to use the other side of it. Okay, better. Now, you're going to put arrows very clearly on each end. Now, right, what's going on here? Yeah. Because x could be negative 5, and then y would be 2 times negative 5, negative 10. That's somewhere, that point is on this line, somewhere there. Okay. So this is what you're going to be doing in your homework. You're going to be evaluating the function, taking those points, and plotting them. But for the most of the time, you're going to be doing it on the coordinate plane. Now, you're going to make a little sketch. You're not going to sit and draw a grid or get graph paper or do any of that. So let's see this. You do make a t-table, so copy this t-table. And we're doing y equals negative 3x. So negative 3 times negative 2 is positive 6. Negative 1, I'm just putting this in there. Negative 3 times negative 1, positive 3. 0 times negative 3, 0. Negative 3 times 1, negative 3. And 2, negative 3 times 2, negative 6. Okay, now, you're going to draw a little sketch of this. Draw it bigger than this, but I don't have room, okay? And you're going to label that your x-axis, that y-axis. So the first point we've got here is negative 2, 6. So you go negative 2 on the x-axis, then 1, 2, 3, 4, 5, 6 on the y-axis. The next point we have is negative 1, 3. So we go to negative 1, 3. You've already made, these little marks are called the tick marks. Don't sit there and make a this whole grid. Don't sit there and go from -10 to +10. Put the marks, the tick marks you need. So -1, -3. We also know 0, 0 right there is already there, right? That's the next point. And you don't have to copy them over. I'm just making sure we all understand what this says. That says 1, -3. So +1 for x, -3 for y. And the last one is, I want to get this y out of the way here, is 2, -6. So then +2, -6. Now, when you draw your sketch, they should all come out in a straight line. Now I'm going to do them on the grid so we all can see them. So I'm redoing this here, right? And there, and there. All right, and then you take your straight edge and you draw a line, a nice long line. You're not connecting the dots. You're drawing a straight line through the dots because there are points off the grid. There's a point if x equals 50, y equals -150. It's somewhere way down there, okay? All right, when we're trying to, we're doing a few sample points so we can know what the line looks like, but there are an infinite amount of points we could do, okay? Please know, all right, you're doing the easiest ones. There is a point where x equals 1/2 and y equals -3 times 1/2, which is -3/2, right? Which is -1.5. And so there is this point, that's this point right here, right? We're plotting the easiest points. We're avoiding the ones with fractions and decimals, but they're there. There's an infinite amount of little points along here, okay? So how many points on a line? Infinite. These are 5 sample points on the line. Y equals -3x. And we call that a linear function. Linear because it's a straight line. Function because when we put x in, we only get one number out, not 2, 3, or more. All right, next thing we got to do. All right, so we're going to do the same thing with a horizontal table. So x is -4. So we put -4 in there. -4 plus 3, -1. Then we put -2 in there. All right, you're copying this table. Then we're going to put -2 in there. -2 plus 3, +1. 0 plus 3, 3. 2 plus 3, 5. 4 plus 3, 7. You don't need all these arrows. Okay, so there's our point. So those are our points that we're going to plot. So negative. So once again, you're making a little sketch like this. And the first point is x, right? X is -4. 1, 2, 3, -4, -1. Try to make them the same space. So right there. -2, +1. 0, 3. Then 2, notice I skipped 2, 5, and 4, 7. Now, right? And you know they have to come out in a straight line, so make sure they do. And so I should see that on your paper. For mine, right, I've got the nice grid there, but it's the same thing. -2, 1. 0, 3, 2, 5, 4, 7. And again, nice long lines. And if you don't have arrows on the end, you lose points because they go on forever. All right, so this is the one we just did. All right, so list 3 more points on this line. Okay, well, there's one there. So you could have said -6, -3. You could have done, let's do this one up here. All right, that's 6, not 6, +9. All right, there's obviously one here at -9, -6. Right, but there are other ones. Say y equals x plus 3. What does that mean? Say I say x is 1/2. That means there's also the point where x is 1/2, y is 3.5. X is 1/2, y is 3.5 is right there, right? It's because it's half is halfway between 0 and 1. 3.5 is halfway between 3 and 4. It's right there. There are ones with decimals in them. There's all an infinite amount of points. These are a few easy sample points so that we can draw the line. Okay, major concept. All right, so we're going to see if this point is on this line. And how you do that is you put the point into the function. Now let's remember that 5 is the x coordinate, the 9 is the y. So we're going to put 9 where y is, we're going to put 5 where x is, and we're going to check the math. So please do that math. And you get 15 minus 6. 15 minus 6 is 9. So that's true, 9 equals 9. So yes. So understand that this, because 5, 9 makes the linear function true, it has to be on the line. Also understand that since 5, 9 is on the line, nothing else with 5, 13, negative 17, none of those can be on the line. Because once you put 5 in there, there's only one output allowed, and we found it. It's 9. All right, so let's try negative 1 as our input. So we're going to put negative 1 in there. And so we're going to get y equals 3 times negative 1 minus 6. So, and then we're going to make y equal to 8, my fault. Okay, so 8 equals negative 3 minus 6. Negative 3 minus 6 is the same as negative 3 plus negative. Well, 8 doesn't equal negative 9. That's nonsense, right? And what that means is negative 1, 8 is not on the line. Negative 1 goes with some other number there. What? It's not 8. What number it is? Well, we could figure it out, right? We just sort of did, right? We did. What y should have been, right, is, let me just write it out again. Negative 3 minus 6. Y should have been negative 9. Negative 1 goes with negative 9. It doesn't go with 8, all right? So this over here is a yes. That is a point on the line. Negative 1 makes one output, and that output is negative 9, not 8. All right. So let's do this one. So we have a t-table, y equals 3x minus 2. So it's 3 times 0 minus 2, negative 2. 3 times 1 is 3. 3 minus 2 is 1. 3 times 2 is 6. 6 minus 2 is 4. 3 times 3 is 9. 9 minus 2 is 7. And 3 times 4 is 12. 12 minus 2 is 10. So we have these points. We have 0, negative 2. You're drawing a sketch. 1, 1, which is right there. 2, 4. 3, 7. Now, and 4, 10, right? Well, those 5 points all nicely came out in a line. So I'm pretty sure I did it correctly. I'm going to draw a nice long line. Now, even though I didn't do points over here, there are points over there, right? Like negative 3 would go in there, and you get 3 times negative 3 minus 2. 3 times negative 3 is negative 9. Negative 9 minus 2 is negative 11. 3 negative 11 is right there. I sort of didn't graph all that accurately, but it's right there. There are all sorts of points. So you want to have a nice long line with arrows on the end. Okay, we're checking whether that is on the line. How do we check? We put the y where y is. You put the x where x is. And so the y is 15. The x is negative 2. Negative 2, 4 times negative 2 is positive 8. 8 plus 7, yeah, that's 15. Yes, that has to be on the line. It makes the math work out. This time, now, we put negative 2 in there and found it had to be 15. Can this possibly be right? No. I mean, truthfully, if you know it's 15, negative 2 can't make any other output. That's why it's important. Part of the reason why it's important for you to understand. An input can only make one output, and we've already made it. It's 15, so it can't be 12, right? Well, if we do the math here, you get 15 equals 12, or no, 15, that's not what you'll get. Oh, now I have to do it. So you're going to get you get 12 over there, and then it's -4 times -2. Yeah, you're going to get 15 equals 12, sorry. Yes, and that's not true. All right, so which one is linear? We have been only doing linear functions. We are going to do the other kinds of functions, but which one is linear? The one that is linear is this one here, because the exponent of x is 1. It is a line. All right, good luck with the homework.